I'm Natalie.
I'm Jacob.
And I'm Josh.
Today we're going to be looking at... I'm so sorry.
That's okay.
Okay,
That's okay.
Okay. Today we're going to be looking at making bioplastics. Bioplastics are common polymers that are commonly found in today's society are toys, plastic bags, adhesive glues, and other objects, and etc.
Awesome. So future scientists, today we're going to be using all these ingredients here.
Starting over here on our right, your left, we have 2.5 grams of starch. Down here we have 2 milliliters of 50% glycerin. The other 50% is diluted with DI water. Right here we have our 3 milliliters of 0.1 molar hydrochloric acid. And then we have 20 milliliters of water, again DI water right here in this beaker. So first we're going to combine them all into the same beaker. We're going to start with our 2.5 grams of starch. I'm going to put about half in first. Use my little stirrer here. Going to mix this up. We want to make sure it's really dilute all the way through to get a homogeneous mixture. Add a little bit more. There we go. We're going to stir it a lot more here in a minute. So that's just to get our first ingredients, followed by our 2 milliliters of glycerin. Really don't need a lot. Mix that up. Part 2 mixed in. Follow with our hydrochloric acid. Notice we are wearing our gloves and safety goggles just to be sure. Lab safety is super important. Awesome. So now we have our mixture of all of our ingredients for our bioplastic.
All right, so we're just going to bring it over to the stir plate here. I'm going to add a magnetic stir bar. Going to turn that up to about 300 or so RPMs. You can see it begin to stir in there, and we're going to add just a bit of heat to about 70 degrees Celsius to bring it up to a simmer, and we'll let that go for about 15 minutes. And we'll see what happens.
See you guys in a little bit.
Hi, I'm Blair Nouse, one of the advisors for our SMACS chapter. I want to interject a little bit for Jacob about how we represent molecules in chemistry. So, if we take a look here we have a structure of 3 units of amylose. And we can see our carbon atoms are represented by the dark gray spheres, the hydrogen atoms by the light gray spheres, and oxygen by red. And we can see, even with just a 3 subunit, this starts to become a complicated looking chain, especially if we want to try to draw it conveniently in 2 dimensions. So, what we do instead is we use line drawings. So here's that same 3 subunits drawn out in a line drawing. And here we can see we don't have all of the carbons labeled. There are any joint in a line, and the hydrogens attached to them disappear. So if we point, we can peek. Here's a carbon and 2 hydrogens. Here's a carbon. Here's a carbon. Carbon in there. And we can see that structure carried out. Back to Jacob.
Awesome. While our bioplastics cook a little bit, we're going to talk about the chemistry behind the process. This is a single subunit for our amylose, and our amylose combines to make our amylopectin. They are combined with a dehydration reaction. And to make our bioplastics, they react with our glycerin. And our glycerin has 3 important hydrogens here that hydrogen bond with these oxygens inside of our amylopectin. And when we get those linkages, we can make our polymer.
Okay, now we have let the solution steer for 15 minutes and now we're about to remove it. Don't forget to use your tongs. Safety first, future scientists. Safety first. And then we have to then weigh out this. Hi again. Now we're about to mix in our solution of 3 milliliters of 0.1 molar sodium hydroxide, which is used to neutralize the hydrochloric acid within our solution. So we're basically adding a base to our solution. Here we go. And now we're going to stir it gently. And now we're going to add it to our petri dish. We have now finally finished making our solution. However, our results will not be shown unless after 2 days. So we'll see our results and how it's going to look like. After 2 days of letting our experiment sit, we have officially obtained bioplastic. Well, I know you're wondering, why are bioplastics important? Well, they're more environmentally friendly, they're more biodegradable, they are able to be recycled easier compared to more petroleum overall products. So bioplastics could be a thing that we could adopt more, because the impact of using the ingredients used to make them is less on the environment than using oil-based or petroleum-based products. In conclusion.